Okay, so 5.5 complex numbers. You know, I know we had to use imaginary numbers over last night's homework, and sometimes it's hard with math to get the sequencing perfect. You know, should we deal with complex numbers first and then deal with what we did over last night's homework? Or do you do it first with just a cursory thought with complex numbers, come back to it? The author chose the latter. Again, sometimes sequencing is a little difficult. Sometimes you got to do something before something else, but then a part of it you wish you could go later. Anyhow, time for complex numbers. All right, so our number system that we've dealt with so far is the real numbers. It's right here. It's the left side. And remember, the real numbers has two parts, though we don't show the two parts. The real numbers has a rational part and an irrational part, but all of those parts are real numbers. So remember, the irrational are like square roots, right? The square root of 7 is irrational, square root of 3, etc., etc. All that's the real numbers. Well, what about the imaginaries? And that involves square roots of negative numbers. And so the complex numbers are those two sets, the real numbers and the imaginary numbers. Put them together and you get the complex numbers. So all the reals, all the imaginaries together is the complex numbers. Complex numbers have this form, A, and use your color here. It'll help you all the way through. And I'm going to use green here for my B. And then after the B comes the I. A plus BI. Nobody has physics yet, is that correct? Nobody in here? So when you get to physics, you'll see A plus BI form, not just in complex numbers, but in vectors. And we'll talk about vectors in this course a little bit down the road as well. A plus BI form. So really what you have is you have the real part, right? A is a real number. And then you have the imaginary part. And if you notice the sequencing from some of the problems last night, that's exactly the way it was given. If there was a real part as well as an imaginary, the real number came first and then the imaginary part came second. That's just standard form. That's the way it ought to be. And that's your sequencing. A pure imaginary number has no real part. The real part is 0. So that's what we're trying to show here. A pure imaginary number, no real part. The real part is indeed 0. Okay, so 5i, that's 0 plus 5i, boring, real part. 0 plus I. Again, normally we wouldn't show the 0. It's only there for illustrative purposes. Okay, so when you add the real part, then it's just an imaginary number. All right, let's get into some graphing. Well, believe it or not, you can graph complex numbers, but they have to be graphed in a, what kind of plane? Huh? Well, not quite Cartesian. Although it looks similar, it's actually called a complex plane. So you need a complex plane. So a Cartesian plane has an horizontal axis, that's the x-axis. A complex plane, the horizontal axis is the, what do you think? It's not the y. It is the real number axis. And the vertical axis then is the, all right, so just imagine it's not there and it'll be no problem, right? No, you better imagine it is there. The y-axis is the imaginary axis. The x-axis is the real number axis. So look, to plot a point is really, really easy. I mean, it's really easy. The point negative 2i, go 2 to the left on the real axis and go up 1. So 2 left and up 1, like how about right there? There's negative 2 plus I. So instead of a parentheses with a comma between, it's just in a plus bi form. So go ahead and plot 3 minus 2i. Should take you just a couple seconds. 3 minus 2i. And hopefully you went right there, right? 3 minus 2i. Where are you going to stick 4i? Oh, there you go. Good old 4 i's. Right on the y-axis. And what would you call the complex number form of z? How would you write z? Put z in complex number form. Point z is in quad 3, right, of the complex plane. And hopefully you said negative 2, what is that, 4 minus 4i? Right? What is z? 2 to the left. Negative 2 is the real part. What's the imaginary part? Negative 4. Negative 2 minus 4i. It's not hard. Piece of cake, right? You would wish we had a lot of those questions on the quiz tomorrow and your test whenever that comes. All right? So pretty simplistic. That's not hard. You got a real part, you got an imaginary part. Piece of cake. All right. Next thought up. The absolute value. This is also called the modulus. Why? So that we can confuse students. All right, the modulus. M-O-D-U-L-U-S. Modulus. Oh, great. Another term. It's just the same as the absolute value. And we already know the absolute value is the, what word goes in the red part there? Distance, right? A number is away from the origin. So here, let me get rid of my screen and let me go higher for you guys. All right, so look at the scenario. We got point F here. Look, whether it's a complex number or whether it's just a point in a Cartesian plane, how in the world do you figure out its absolute value? It's basically the concept of using what? What concept do you use to figure out the distance of a point in a plane from the origin or a distance of a complex number in the complex plane to the origin? How would you figure it out? What's the main concept? We've done this before. You've done it before. How are you going to figure out how far it is from F to the origin? Julia? Okay, you could, all right, but how many of you remember the distance formula? Let me see your hands. Yeah, exactly. But how did I tell you how to remember the distance formula? I told you the distance formula comes from, all right, you're going to make me do it, aren't you? Comes from, oops, that should be red. Give me red. Comes from the distance formula comes from which what thank you, finally here, the Pythagorean Theorem, right? So calculate it using the Pythagorean Theorem. That's the distance formula. That's the Pythagorean Theorem. Pythagorean. Which if you solve the Pythagorean Theorem for C equals the square root, I'm going to use my color here, of A squared plus B squared. And look, we even have A and B. What could be easier? Doesn't complex number form have A and B? So it's a piece of cake. It's the Pythagorean Theorem. So let's use point F here. So hopefully you agree point F is what? 3 plus 4i. And 40% of you already know the answer, right? How many already know the answer before even figuring the Pythagorean Theorem? Come on, look at it. 3 and 4. The distance is? Thank you. 3, 4, 5 triangle, right? You say, but it's imaginary. I don't know what to do. Well, just imagine you know what to do and get the answer. It's just the Pythagorean Theorem, right? Don't Don't make it something more than it is. It's just a Pythagorean theorem. So look, all you're going to do is, you're going to do the square root of 3 squared. And here's just one thing you got to be careful about. You don't use the I. It's just the 4 squared. Okay? Because the I is what the axis is. So it's simply the square root of 3 squared plus 4 squared. And again, I'm not going to go through all of that. That's the square root of 25. And what's the absolute value of point F, the distance from 0? It's 5. That's pretty easy. Yes, ma'am. All right, Sarah, so if you'll go with Mr. Ritigliano. Okay, fair enough, easy enough. So go ahead and figure out the absolute value for B. Gave you guys one that doesn't even simplify. How nice. All right. By the way, sometimes I won't say find the absolute value, right? I'll just give you the symbol, and you know that's the absolute value symbol. So square root of negative 4 squared plus 5 squared. And by the way, you don't need to do negative 4 because any negative times a negative is a positive. I just put it there for some of your sake so you wouldn't get confused. All right, square root of 41, easy enough. Questions? What a waste of breath. All right, C. Got to figure out how to get you guys out of that. All right, so same scenario, right? We're just looking for the absolute value. Look, this shouldn't be a long, arduous process. That's a 4 squared. Look, if you want to do negative 1 squared, knock yourself out, and negative I is a negative 1I. But negative 1 times negative 1 is positive 1. And this is what, the square root of 17, and that's it. Now again, sometimes you'll get a radical that you can simplify. You should always be looking out for radicals that you can simplify. Okay? So that's pretty easy, absolute value. Now you're really going to have to focus, because now we got to add complex numbers. And I always have to really get people woken up. All right, are you awake? Is there life out there? I don't think so. All right, you got focus. Are you focused? I don't want you to miss this, because you miss this, it's going to be hard. All right, here we go. We're going to add 7 minus 2i plus negative 3 plus I. Here we go. Are you ready? This is hard. Stay focused. 4. All right, don't lose focus. Uh-oh, that's a 1. Negative I. Okay, did you catch it? I know that was hard. Huh? What? Don't you like that? 7 minus 3 is 4. Negative 2 plus 1 is negative 1. Huh? What am I missing? What do you guys don't like? Oh, the 1 in there? Oh, that's just for emphasis sake. Thank you. Couldn't get what you guys okay, did I add wrong? What in the world? It's always possible. Hey, just add the real parts, add the imaginary parts. Boy, that's pretty easy. All right, piece of cake, no sweat. So obviously, when you get to something like this where you're subtracting, the key would be to do what? Right, like everything else, just make sure you distribute the negative. So what, the real part is negative 3, and the imaginary part is negative 13. And that's so hard, I'm shaking in my boots. Pretty easy. Lots of those on the quiz. Yeah, like 1. All right. Sorry. Okay. How about multiplying complex numbers? Well, how about distribute? Gee, we don't know how to do that. I would put an asterisk over here with the remember, because whenever you multiply an I times an I, you get an I squared, and you go from the imaginary realm to the real realm, right? Because I squared is a negative 1. You can't forget that. We're going to talk about that a whole lot more here in just a moment. So does that always apply? No, it depends on the scenario. So what's A? 28 minus 8i, right? 4 times 7 is 28, and 4 times a negative 2i, negative 8i, that's it. Done. What could be easier? Okay, so you're just distributing. Second one, you got a 6. You got a positive 15i. Now I got to distribute the negative 2i. You got a negative 4i. And in the back, you got a negative 10i squared. And again, be careful with that negative 10i squared. That I squared is a negative 1, right? So that I squared is a negative 1. So do you agree the back is a positive 10? So I'm going to put the real parts together. Positive 10 and 6 is a 16. And I'm just going to add the like terms for the imaginary part. And that's a plus 11i. So multiplying two complex numbers. Hey, we know how to do that. We know how to multiply two binomials. Just got to remember the I squared is a negative 1. It's the only trick to that. Everything else we know what to do. It's just multiplying two binomials. What if you've got some radicals involved? Oh no. Well, it's the same concept. By the way, what kind of a situation do you have in C? What is C? Even though it's imaginary, it's still a Luke. It's still a what kind of two binomials multiplied is this? Difference of two squares, right? By the way, they're also conjugates, right? Exactly the same. One's a positive, one's a negative. All right, so because I know a difference of two squares, I can do a shortcut. 5 times 5 is 25. I'm not going to multiply these, right? Because the negative 2i, oops, I got to do it this way. The 5 times the positive 2i times the square root of 7, and the negative 2i times the square root of 7 times 5 gives you the positive and negative, right? Difference of two squares are going to add out. If you don't remember it, just multiply them out. They're going to add out. In both cases, you're going to have what? Positive 10i times the square root of 7 and a negative 10i times the square root of 7. Agreed? So they're gone. So the only thing left is the back part. Negative 2i times a positive 2i is a, negative 4i squared. And square root of 7 times square root of 7 is 7. So that's a negative 4i squared times a 7 in the back. And on top of that, an I squared is a negative 1, right? So what's the back part? The back part is a positive 28, right? So in this scenario, you end up at 53. So again, we ended up with a real number answer. Okay, do you guys have anything else on your page? Do you have that on your page? You don't. You do? Okay. All right. All right, number 7. An imaginary number is any, and I'm going to use my red here, even root of a negative radicand. We've stated this before. I just want to put everything in context here. So an imaginary number is an even root of a negative radicand. So for example, if we had the square root of negative 5, and let me get rid of this and go higher. If we had the square root of negative 5, you would be asking yourself what number times itself 2 times equals negative 5, and the answer is none. So again, we talked about this yesterday, well actually Friday, but I just want to bring us all back to it because we're going to get ready to do a whole bunch with imaginary numbers. So by definition, the square root of negative 1 is the I. And so remember what we talked about on Thursday. what is technically the square root of negative 5? I'm right here now, right? It's technically the square root of negative 1 times a 5, which is a square root of negative 1 times the square root of 5. There's your imaginary part. So you end up with I times the square root of 5. Is that technically in proper form? And the answer is no. Look, if I was going to write this as a complex number, I would write 0 plus, and technically the coefficient's supposed to go in front and the I in the back. But here's why we stick the I in the front. So sometimes it's hard to determine if a person means that or if a person means that. Is the I inside or out? And it matters. It could be inside. You could have the square root of 5i, and the I is part of the radicand. And it's kind of hard to tell. And especially when students write it, it's hard to tell. So what do they mean? Do they mean this, or do they mean that? And we're not sure. And so to be sure, we stick it in the front, even though technically it should be in the back. Do you follow? So again, the I goes in the front of any radical so that we're sure it's not under the radical sign. It's not part of the radicand. Fair enough? I need not ask because you guys don't answer anyhow. All right. You guys have that already. We just did that, right? Is that in your notes? My notes are different than yours. Again? All right. Don't worry about it. Just skip it. I changed something, and obviously I didn't make all the changes I want. Okay. Here's what I want to get to. You got to learn this key pattern of the values of I. And I've got a couple minutes to make the point. Now, I know that looks like a lot. Let me get rid of some of it. Let me go this way. Okay, so just stay with me. This isn't very complex, but you do have to be careful. Okay, I to the first is the square root of negative 1, which is simply I. However, I squared is the square root of negative 1 times the square root of negative 1, and we've already said that that equals negative 1, right? And that's a key one. I squared is key because now the imaginary numbers are gone and it's a real number, negative 1. What if you had I cubed? Well, remember the I squared is a, oops, let's do it this way, be easier. The I squared is a negative 1, right? From previous times an I. So now we have negative 1 times I. So an I cubed is a negative I. And then an I to the fourth is an I squared times an I squared. What's an I squared? A negative 1. What's an I squared? A negative 1. And negative 1 times negative 1 is 1. And there's our pattern. I, negative 1. Negative I, 1. And everybody should learn that pattern. I, negative 1, negative I, 1. I, negative 1, negative I, 1. So let's now go to I to the fifth. Guess what? I to the fifth is I. And I to the sixth is negative 1. And I to the seventh is negative I. And I to the eighth is 1. Because it's I, negative 1, negative I, 1. I, negative 1, negative I, 1. So I to the ninth is, and I to the 10th is, and I to the 11th is, and I to the 12th is, and I to the 13th is I, and negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative, all right. Good, beautiful. Got to remember that. Come on up here, Hunter, you can lead it. No, all right. Time's sake. Okay, so you guys will get problems like this. Simplify I to the 18th. Well, here's the key. You got to remove as many I to the fourths as possible. Because what's an I to the fourth equal? 1. So you're removing ones. So would you agree an I to the 18th is I to the 4th times I to the 4th. There's 8 of them, 12 of them, 16 of them, and there's the last 2 of them. Do you agree? And what's I to the 4th? 1, and I to the 4th, 1, and I to the 4th, 1, and I to the 4th, 1. See, we could just get rid of them because they're all 1. And the only thing we care about is I squared at the end, and therefore I to the 18th is -1. Awesome. You guys are so bright. Well, what if they give you like I to the 3,741st? We don't want to count out I to the 4ths. So we have an easy way. We can use our calculator. Because look, in reality, this can be done by dividing the exponent by 4. Because the pattern involves fourths. I, -1, -I, 1. I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. So look, here's the reality. If your remainder is 0.25, it means you had an I left. And what is an I? It's an I. If you have a 0.5 remainder, you have an I squared left. And what's I squared? -1. And if you have a 0.75 remainder, you have an I cubed left, and that's a -I. And if you have no remainder, it was 4 divided by 4, it was I to the 4th, and it's 1. You're just reading your remainder. So grab your calculators. Yo, calculator. So what is first one? 39th? So just take 39 and divide it by 4. Now, if you remember the pattern, what's your remainder here? 0.75. I could care less what number's in front. All I care about is my remainder. 0.75 means 3/4 or I cubed. So this is an I cubed, so this is a -I, right? Okay, watch. I know a few of you are confused. Look, let me go higher for you here. So look. Do you agree 0.75? Any problem with that? 0.75. Did you take 39 and divide by 4? Do you get 9.75? Okay, it's the 0.75. 0.75 was a 3/4, means an I cubed, and the answer therefore is -I. Every time. Anytime your remainder is 0.75, it's I cubed, it's -I. So let's try it again with the next one. So go ahead and take, what is that, 122? 122 divided by 4. What's my remainder? Oh, 0.5. 0.5 is an I squared, right, according to the chart? And what is an I squared? It's -1. Catching on? Do the same thing with the 741. 741 divided by 4 is, I could care less about the 185. That's all just a bunch of I to the 4ths, right? The 185 is just, there are 185 I to the 4ths, but they're all 1, so who cares? And we have 0.25 left over, and that's all I care about, and that's an I, so the answer is I. I. Okay, don't pack up yet. I still have a couple minutes. Give me my minutes. Because let's see if we can wire your brain. Okay, so what do we start off with? Complex numbers, right? A real plus an imaginary part. A plus BI form, that you should know. Complex plane, real axis, imaginary axis. Everything else just like we would expect in plotting. Absolute value, or another name for it, the modulus. Pretty easy. It's the Pythagorean Theorem. The square root of the real part squared plus the imaginary part squared. Don't use the I, right? Just the coefficient. Adding complex numbers, boy, that's really hard. Add the real parts, add the imaginary parts. Multiplying them, not a problem. Distribute. Just remember I squared is a -1. Factor in that -1 whenever you get an I squared. Talked about imaginary numbers there. So what is an imaginary number? Even root of a negative radicand. Square root of negative 1 is the I. Went through the pattern. I, negative 1, negative I1. So if you add an I to the 741st, divided by 4, read the remainder. Remember, a 0.25 is a 1/4, I to the first. A 0.5 is a 2/4, I squared, which is a negative 1. 0.75 is a 3/4, I cubed, which is a negative I, because you know the pattern, I, negative 1, negative I1. And no remainder was in 4/4, and voila. All right, that's it.